In this video, I'm going to solve a problem that was posted in the comments section of a previous video that I did. So this is a dynamics question that someone would run into when completing the grade 11 physics course. And this problem deals with multiple objects, in this case 2 objects, connected to each other. So a 24 kilogram box is tied to a 14 kilogram box with a horizontal rope. The coefficient of friction between the boxes and the floor is 0.32. You pull the larger box forward with a force of 1.8 times 10 to the 2 newtons at an angle of 25 degrees above the horizontal. Calculate A, the acceleration of the boxes, and B, the tension in the rope. So in this video I'm going to solve part A, and then in the next video I'm going to do part B. So let's take a look at what this situation looks like. So there are 2 boxes. There's a larger box that has a mass of 24 kilograms, and it's connected to a smaller box that has a mass of 14 kilograms. Now, in order to solve the first part of this problem, you're going to need to treat this as a system. You're going to have to treat these objects as a single object. So what's going to end up happening is that you'll combine these 2 boxes and make them into one large box. Okay? Then after you've done that, at this point, you would want to draw a free body diagram. So using this large box, I'm now going to draw the forces that are acting on the system. So there's an applied force of 180 newtons. So I'm going to draw it here. So it's 180 newtons. And there is also a force of friction acting on both boxes. So it's opposing the applied force. So force of friction. Since this object is on Earth, there's a force of gravity acting on the object. So Fg. And then lastly, there is also a normal force acting on the object. So it's the force of the floor on the box. So since the box is applying a force on the table, or the floor in this case, the floor is also applying a force on the box. So now what I'm going to do is I'm going to break this force up into its components. So since this vector is at an angle, it has 2 components. It has a horizontal component, and it has a vertical component. And the angle here is 25 degrees. So the horizontal component would be 180 times cosine of 25, and the vertical component would be 180 times sine of 25 degrees. And so I've covered this in the previous video, how you resolve a vector into its components. So if you take a look at my previous videos, you'll learn how to do that. So once I've broken this into, once I've broken the applied force into its components, I'm now going to go on to writing an F-net statement. Okay, so I'm going to start by writing an F-net statement that is in the horizontal plane. So F-net x is going to equal, so the horizontal component of the applied force, which is 180 times cosine of 25 minus the friction. The friction is opposing the horizontal component of the applied force. Now I'm assuming that the box is going to end up moving to the right, since the question is asking for the acceleration of the boxes and the applied force is applied to the right side of the box. So the right side in this case is going to be the positive direction. So values to the right are going to end up being positive. So if I create a sign convention, the sign convention would look like this. So to the right and up would be positive. Okay, so now I'm going to write Fnet as mass times acceleration. So, and it's the mass of the system, so of AB. So AB weighs 38 kilograms because so if I've combined these two boxes into a single box. So when doing that, you have to add the masses. So mass of AB times acceleration, what we're going to be solving for, is equal to 180 cosine of 25 degrees minus, and what I'm going to do now is I'm going to use the formula for determining the force of friction. So the way you can determine the force of friction is you can take the coefficient of friction, mu, and multiply it by the normal force on the object. So quickly you'll notice that you're going to have to find the normal force. So we have mu, we have the mass, we're just missing the normal force. And so in order to find the normal force, I'm going to have to write an Fnet statement for the vertical plane, for the vertical dimension. So in this case, I'm going to have, so in the vertical I have Fn, and I also have the vertical component of the applied force. So those two are going to add together, since they're both in the same direction. So Fn plus 180 times sine of 25 is going to end up equaling the force of gravity, Fg. And that's because this box is not accelerating in the vertical plane. Okay, it remains stationary with respect to the vertical plane. So that means that the forces in the vertical plane have to be balanced. So the normal force plus the vertical component of the applied force have to add up to the force of gravity on the box, for the box to remain on the floor and not to fly up or go through the floor. So that would end up becoming Fn plus 180 sine of 25 is equal to the mass of the box times the force of gravity. So recall that this is equal to mg. So the mass of the box is 38 times the acceleration due to gravity, 9.81. And so isolating for Fn is going to equal, so 38 times 9.81 minus 180 times sine of 25 degrees. And that would end up equaling 296.71 newtons. Now I'm going to take the Fn value that I found and I'm going to substitute it in here in this equation. I'm going to replace the mass of AB with 38. So 38 times A is going to equal 180 times cosine of 25 minus 0.32, the coefficient of friction. In this case, the coefficient of kinetic friction, since the two boxes are moving, times the normal force, which is 296.71. And so I'm going to end up getting 38 times A is equal to 68.188. Then dividing by 38 leads to 1.79 meters per second squared, since it's an acceleration. Now, since in the question most of the numbers are only to two significant digits, the final answer should also have only two significant figures. So the final answer is 1.8 meters per second squared. In part 2 of this video series, I'm going to solve for the tension in the rope that is between the two boxes. If you enjoyed this video and found it helpful, please give it a like, and also please subscribe to my channel. See you in the next video.